Okay, so we are on section 4.4, but we're on part 3. So if you have not watched part 1 or part 2, make sure you go back and watch those in that order. So we're going to talk about some definitions today. We're going to start with one that we already know. The definite integral is a number. So that's what we've been doing, where we have boundaries. So from a to b of f of x dx. So a and b are our constants. So a is our starting point. B is our ending point. F of x is our function. And dx, that is tells you the variable that you're working with. So back when we did an infinite amount of rectangles, f of x was the height of our function, dx was the base, so the distance on the x-axis that each rectangle represented. So over here on the right, we're going to talk about the definite integral as a function of x. So when we take an integral, we can also label it with a capital F. It's something that if you forget, it's not a big deal, but if you ever see a capital F, that means they got that answer using an integral. So sometimes you'll see, instead of a and b, you might see a variable up here. So a might be a constant, and up top you might see a variable. And then you'll have your function. I'm going to use t instead of x just so we don't confuse the two variables. dt. So what you're going to do is you're basically going to solve just like normal. You're going to take the integral and then you're going to evaluate top minus bottom. So we're going to practice that a couple times here. And this is called the second fundamental theorem of calculus. So theorem 4.11. Sometimes they'll even ask you to take the derivative of an integral. And what we know about derivatives and integrals, they cancel out. So if that happens, you just get the part inside the integral. Now, one extra part to this, I'm going to add this over to the side, is let's say you take the derivative of an integral and you have something other than x. So let's say it's x squared. You would still cancel out the derivative and the integral, so you would get f of x. But if you have something other than x up here, you're going to multiply by the derivative of it. So if you have x squared, you're going to multiply by 2x. So that's just one extra piece, and that only happens if you take the derivative of an integral. They just cancel out except for if you have something other than x, because the derivative of x is 1. You don't have to do that for that one. But if it's anything other than x, you multiply by the derivative of that number. Okay, so let's try with number 1. We're going to evaluate the integral from -2 to x of t squared minus 2t dt. So first thing I'm going to do is take the integral. So that's 1/3 t cubed minus t squared. And I'm going to evaluate from -2 to x. Next step, we're going to do top minus bottom. So I'm going to plug in x first, minus, now I'm going to plug in -2, and now we're going to evaluate. So over here, I can't evaluate anything because I don't know what x is. So I'm just going to leave it as 1/3 x cubed minus x squared. And then this part right here, I'm going to evaluate, and that's going to become my constant at the end. So -2 cubed is -8 divided by 3. So I'm going to put a -8/3 minus -2 squared is 4. And I'm just going to solve that. So that's -8/3 minus 4. That gives me negative 20/3. So I'm going to write my final answer, 1/3 x cubed minus x squared. And it's a negative 20/3, but that would change it to a positive since I have two negatives, so plus 20/3. Okay, moving on to number 2. So number 2 I'm going to rewrite first because 10 over v squared I can write as 10v to the negative second dv. First thing, we're going to take the integral. So I'm going to add and divide. If I add 1 to negative 2, I get negative 1. If I divide by that, I get negative 10v to the negative first. I'm evaluating from 1 to x. Okay, now we're going to do top minus bottom. So I'm going to plug x in first, minus, and I'm going to plug 1 in next. So over here, this gives me negative 10x to the negative first, or we can write that as negative 10 over x. And then over here, 1 to the negative first is still 1, so negative 10 times 1 is negative 10. That would turn it into a positive 10. Okay, now I'm going to flip it to the back and do a couple extra problems, because we didn't really do any examples where we're taking the derivative of an integral. So I'm going to add example number 3 here. Let's say you're taking the derivative of an integral from, let's see, 3 to x of 2t minus 1 dt. So I just made that up. But whenever I take a derivative of an integral, they're opposites. They undo each other. So if I went through and did all of the work here, so I'm going to do all the work on the side, and I'm going to show you why that works. If I take the integral of 2t minus 1, so I'm going to work with the integral first, that would be add and divide, so t squared minus t. I would evaluate from 3 to x, so we would plug in our top number first, x squared minus x, minus, then I would plug in the 3 squared minus 3. That would give me x squared minus x, and then 3 squared minus 3. That would give me 6. So that's just the integral. But now if I take the derivative of that, because it also says now take the derivative, I get 2x minus 1. So I don't have to do that work every time because I know a derivative is going to undo an integral. So really all we have to do is change the variables, because when we take an integral, we plug that number in. So 2t minus 1 becomes 2x minus 1, and we're done. So, and I talked about this on the front, sometimes you're going to get a problem where that x is not an x. It might be x cubed. It might be anything but an x. So I'm going to use the same problem, but I'm going to change that x to an x cubed. So instead of doing all this work, I'm just going to plug in my variable. But this time my variable is an x cubed, not an x. So I'm going to replace that t with an x cubed. So that's 2x cubed minus 1. And I'm also going to, using that fundamental theorem of calculus, multiply by the derivative of that number that I'm plugging in. So the derivative of x cubed is 3x squared. So I'll give you one more for practice here. Let's do number 5. Let's take the derivative of the integral from 1 to 2x of 4t dt. So a derivative and an integral cancel. So what I'm going to do is I'm just going to replace my variable. So for t, I'm going to use 2x, which gives me 8x. But I'm going to multiply by the derivative of 2x, which is 2. So that becomes 16x. Now, the long way to do this would be to do all the work, right? You take the integral, do top minus bottom, and then take your derivative. You'd get the same answer. But this is the shortcut, and this is called the second fundamental theorem of calculus. Okay, so that concludes our part 3 video. Feel free to go back and rewatch anything that you struggled with, or you can email me or message me through Google Classroom with any questions that you have.